Hi everyone, this is Ms. Frazita. We're looking in calculus at 3.4 section, and this is basically word problems. And again, we're thinking of derivative as slope, but also as rate of change. So here in this section, we talk a lot about velocity, but there's other types of word problems as well that all have to do with a rate, something changing. Okay. So I put good stuff to know. The notation is, I guess, something to memorize and make sure you're comfortable with. S is often used for distance or displacement of a function, so S of t. And then when you take the derivative of S with respect to t, you get velocity, v of t. And if I take the derivative of that, so I would have either S double prime or v prime, whichever way you want to think about it, what I get is acceleration, a of t. Okay, so SVA, definitely need to remember. So you might recall yesterday when you were doing section 3 problems that they were having you practice finding the second derivative, which was, I guess, a setup for calculating acceleration in today's assignment. Okay, so I have a slide packed here with information about velocity. So velocity is a rate, so you have to remind yourselves a rate is really just a fraction. And most of the time, the bottom of the fraction is going to be represented by time. So the top of the fraction is whatever the problem, whatever the word problem happens to be about. So it could be that the distance is changing over time if we're dealing with a velocity problem. So your notation could be ds dt, where s is representing distance and t represents time. You could call it s prime of t or v of t. All of these are ways to represent velocity. Now the units for velocity, since velocity is a fraction, a rate, you want the units to be a fraction or a rate as well. It's meters per second or feet per second or whatever the unit of distance is per whatever the unit of time is. Okay, so since we are going to have to be reading some graphs in this section, it can get a little confusing when you're looking at the graphs, you know, what exactly it means if your graph is above the x-axis or below it, or the slope is positive or the slope is negative. So try to kind of summarize things here. So a negative velocity simply means that the object is traveling in a downward direction or a left direction, whatever negative direction is. Okay, so again, negative velocity is just telling you that it's going, you know, in the negative direction. So if you think of miles per hour on the freeway, okay, you're 55 miles an hour or 65 miles an hour. Typically, we talk about 65 miles an hour. We don't say negative 65 miles an hour because it's a speed limit, not a velocity limit. But if you were on, let's say, Highway 5, and you're heading south going down to LA, technically you could say your velocity is negative 65 miles an hour because you're heading south. All right, when you make your return trip from LA heading back to the Bay Area, you would be going a positive velocity of 65 miles per hour. So that would be just velocity being positive, meaning that you're heading in the positive direction. Zero velocity, well, you're not moving. Okay, if your velocity of zero, you're not going anywhere. So difference between speed and velocity, I alluded to it a minute ago, but your speed is always a positive number. So when we have a speed limit on the freeway, they never give it as a negative number. That would be silly. So speed is just absolute value of velocity. So it doesn't really take into account the direction. And the last thing here, it says if you're looking at a graph of distance on the y-axis and time on the x-axis, the maximum and minimum points on your graph are going to be where your velocity is zero. Okay, so if you think about an object that's moving in the positive direction, stops, turns around, and moves in the negative direction, then that point where it stopped must be a minimum. The velocity when it stops is zero. Might want to play that one again if you need to. Okay, let's go on and talk about acceleration. So same kind of thing, acceleration is also a rate, but this time the rate is you're comparing velocity, or how quickly your velocity is changing, compared to how much time has passed. So velocity on top, time on bottom. So again, you would have a dv dt for the derivative, or you could say v prime, Or remember, it's really the second derivative of distance, s double prime. So if you have a distance equation, s of t, you would have to not only find its first derivative, but find its second derivative to talk about acceleration. So your units, if you think of it as velocity changing over time changing, velocity is meters per second time seconds. Or you could say, if you simplify that, s and s there, it's meters per second squared. Or of course, maybe you're in feet, so feet per second, or feet per second squared, whatever, something similar to that. So negative acceleration versus positive acceleration. If it's got a negative acceleration, the second derivative negative, that means that your object is slowing down. And if it's a positive acceleration, it's speeding up. It's a little bit more complicated than that, but I started us off with just this concept here. Acceleration being 0 means that it is still moving, it's just not accelerating, which means that it's going at a constant velocity. So if velocity is 0, the object's not moving. If acceleration is 0, then the velocity is constant. Okay, gravitational constants. Oftentimes in these word problems, they'll talk about gravitational force. Remember G, probably know from some science classes, your gravitational constant is 32 feet per second squared, or if you're in meters, it's 9.8 meters per second squared. That's basically having to do with the gravity on Earth. Okay. If looking at a graph of distance versus time, when it's linear, the acceleration is 0. So again, if the y-axis of a graph is distance, time is on the x, and the graph is actually a straight line or a nice line somewhere, then you know that the slope of the line is the velocity, and the fact that that slope is constant because it's linear tells you that the second derivative of distance would be 0. Acceleration is 0. That probably sounds pretty complicated. Let's go ahead and take a look at the example. Okay, so trying to read our graph here. I put time on the x-axis as always, since time is our independent variable. It always goes on x. Velocity on the y-axis as our dependent variable. So first question, when does the body move in reverse? All right, so we know that the object would be moving in the negative direction if the velocity is negative. This particular picture has the velocity as the y-coordinate. So I'm looking for the y-coordinate to be negative. It's this portion of the graph that's red. Hence I wrote it in red. When it's below the t-axis, velocity is negative. Okay, next question. When is the body moving at a constant speed? Well, constant speed, same thing as constant velocity, as long as we don't care about it whether it's negative or positive, right? Speed's absolute value of velocity. So when is it moving at a constant velocity or speed? Well, that means that the velocity is not changing or the speed is not changing. So this part right here, which is a horizontal line, would have a constant velocity of 0, meaning it's not moving. But also, this part at the bottom that has a horizontal line would be when the speed is not changing, the velocity is constant. The only difference between this part down here and this part here, this one in blue, the velocity, the y-coordinate, right? The y-axis is velocity. The y-coordinate is 0, meaning the velocity is 0, it's not moving. Here, the velocity is negative, so it's moving at a constant speed, and the actual speed would be, I'd have to count these, the y-coordinate, 1, 2, 3, 4, 5, 6, 7 maybe. So -7 is the velocity, so the speed would be 7, I don't know, miles per hour, whatever. But it would be constant because it's a horizontal line there. When does the body move with its greatest speed? Well, greatest speed would be basically the time that it's furthest from the t-axis or x-axis. So this point here looks pretty high up, but this point down here looks even further away from the t-axis. Since they said the greatest speed, not greatest velocity, I don't care about the sign being negative, right? So this is further from the x-axis than it is up here. So my answer would be all the values of t in between here. I don't have a scale marked on here. I don't feel like counting the boxes, but whatever number this is over to whatever number this is. from t being here to t being there is going to be when it's moving with the greatest speed. Okay, then just to make sure everyone was thoroughly confused, I threw in question 4. So answer the questions again. This time, picture the y-axis not being velocity. Picture the y-axis being distance. Answer the same 3 questions. Okay, just picture up here, this is distance on the y-axis. So when does the body move in reverse? Okay, so if the object is moving in reverse, that means the slope needs to be negative if we're looking at a distance graph. So this portion here has a negative slope, which means the distance is getting closer and closer to the starting point. You know, it seemed like it was moving in the positive direction initially, stopped and turned around, and then it moved in the negative direction. So it's moving in the reverse or in the negative direction when the slope is negative, and then over here, okay, the distance is 0 as time passes, and then it moves in the negative direction again. So this portion also, the t values in between whatever this coordinate is and this coordinate, right? That's the negative slope. And then again, it wouldn't, the distance wouldn't be changing, and then the distance is, well, it's moving back toward where it started from at the end. Okay, when is the body moving with a constant speed? So again, if we're looking on the y-axis as being, looking at the y-axis as being our distance, then speed we know is the derivative of distance, and derivative means slope. So we're looking for a constant slope, meaning a line segment. So basically all these parts are going to be constant speeds. So between t equals 0 and t equals 2, it's moving at a constant speed of, and I could calculate it, right? Rise over run to get the slope. 1, 2, 3, 4, 5, 6 over 2. So 3, it's having a constant speed of 3 meters per second or whatever. And then it would have a constant speed of negative whatever. And then it would not have any speed at all because it's not moving. And then it would have a constant speed in the negative direction, not moving at all, and then a constant speed here. When does the body move with its greatest speed? Okay, so again, we're still thinking of the y-axis as distance. Greatest speed means the largest slope. So you're going to look at how steep these lines are. So this one we said had a slope of 3. We could look at this one and see what its slope is. Speed, so I don't care about the negative sign, even though the slope, of course, is negative here. I could not worry about that minus sign. So just from eyeballing it, I would say this red line here and this red line here, assuming that they are the same steepness, one's going up, one's going down, but the same steepness, I think that would be my answer. So whatever this t value is to this t value, that would be when it's got its greatest speed. And also from this t value to this t value, it would have the same speed. Okay. Sorry if this is sounding complicated. It really does take some practice and it's not easy. And of course, some people are advantaged if they have had physics before or taking physics now. You know, if you don't have a physics class in your schedule now and you've never taken one, you know, don't worry. We'll keep practicing them and you'll get it eventually. Okay, so I mentioned at the beginning that not only do we have questions in here about velocity and acceleration, kind of physics problems, we also have economics questions. And for economics, I again don't want to assume that you've taken an economics class, so I just put the basics in here. Profit, revenue, cost. So your profit is basically how much money you make from clearing, you know, you pay off all your expenses. It's how much you actually cleared. Okay, your revenue is not the same as profit. Revenue is how much money you collect from whatever it is you're selling. Your revenue, chances are, will be larger than your profit if you're having a good business day. Okay, so your revenue should be higher because you subtract off your cost, okay, maybe the overhead that you had to pay for whatever it is you're selling. And then what you get left over after you pay off your cost would be your profit. So we have this simple equation. Profit is always equal to revenue minus cost. This equation you need to have memorized for sure. Okay? So in terms of calculus, they have this word marginal that they like to throw around. What is the marginal cost? What is the marginal profit? And so on. So what does marginal mean? Basically, it's going to be, if we're talking about marginal cost, it would be the rate of change that the cost is occurring with respect to how much the production level is. And this sounds really confusing as well. So let's try an example. So here we have an electronics company, and it estimates that the cost of producing X components used in electronic toys is given by, and here's our equation. They label it C for the cost equation. Okay. So the question says find the cost and also the average cost and also the marginal cost of producing 500 units. So the straight up cost is just you plug 500 in for X. You have 500 units that you're selling, and you're wondering how much is it going to cost to make these 500 before you even bother to sell them. Just plug the 500 into the equation. So C of 500 comes out 250, let's say, dollars. So that's the cost of producing 500 items. The average cost basically means for one item, what does it cost? So, So if the total cost for all 500 items is $250, let's say, and we have 500 items, then 250 divided by 500 should give you a half or 50 cents. Okay, I did that one down here. If you want to, you can go back to your original cost equation, plug in the 500 there, and remember you're dividing it by how many items you have, which is 500, sorry. So anyway, whether you want to do it this way or this way, same thing, 50 cents a piece. Okay, marginal cost now. So marginal cost, you basically find it by calculating the derivative and plugging 500 into the derivative. So here's my derivative. I got that from power rule. So derivative of 200 is just a derivative of a constant, which is 0. Derivative of this is just the coefficient. Derivative of this, I use 2 times this. Okay? So it comes out just 15 cents, let's say. So that means 15 cents is the marginal cost of producing the next item. So what exactly conceptually is marginal cost? So if I have 500 items, it doesn't necessarily mean that each item cost me 50 cents to produce. That's not reality. Chances are the first couple items that you produce of something are going to cost a lot more money. So let's say I'm selling t-shirts and I want to produce, it's a small club, so I'm just going to produce 10 t-shirts. The cost of the first t-shirt is probably pretty darn expensive. And then the later t-shirts, the 10th t-shirt, it's not so expensive because when you make the t-shirt, let's say you have to pay someone to do the art design and you have to actually get a silk screen made, right? Those things you're going to pay for whether you make 1 t-shirt or 100 t-shirts. Okay, so that very first t-shirt, pretty darn expensive. But if you make 2 t-shirts, you can kind of share the expense between the 2. But the actual first t-shirt to make was a lot more expensive. The second one, you just run it through the silk screen again. Right? So if you're trying to figure out how much is it going to cost to produce the next item, let's say you already have 500 of these electronic toys made, or the components for them made. Okay, how much does it cost you to make just one more? Okay, 15 cents is the cost it's going to be to produce the 501st item. Now, again, the average cost is 50 cents an item when you're producing 500. If I produce 1,000, I would expect my average cost to go down because that next item is cheaper than it is to produce the one before. Hopefully that makes a little bit of sense to you. So the 15 cents is actually how much it would cost to produce just that one next component that happens to be the 501st item. Okay, much less than the average. So For your practice problem, you're going to try one from the book. So hopefully have your book with you. Look at section 4 with the word problems and try number 16. It is an even, so you can't check your answers in the back of the book. So please write it out and we'll have the answers on the board you can check tomorrow. That is it. Thank you very much for listening. Hopefully this helps for your word problems.